TCP/IP is a set of protocols that makes the internet possible. TCP/IP, or the Transmission Control Protocol and Internet Protocol, is a suite of communication protocols that specifies how devices exchange data over the internet. TCP/IP is designed to make networks reliable, with the ability to recover automatically if any device on the network fails. But there's no security built in. After watching this video, dig deeper on vulnerabilities to look for at the link above or in the description below. And be sure to subscribe to Ion Tech for more videos on all things business tech. Even though we say TCP/IP, TCP and IP are actually two separate protocols with specific functions. Broadly speaking, TCP is a transport protocol, while IP is the communications protocol. When combined, they create the TCP/IP protocol suite. TCP manages how a message is broken down before being sent over the internet, and how it gets reassembled at its destination. It establishes a connection between the sender and receiver before sending data, and it can control the size and rate of data packets. TCP uses IP to transport packets, but it can also connect computers, apps, and web servers to ensure smooth communications. IP is a Layer 3 protocol that only concerns itself with data communications across networks, including the internet. While it defines data destinations and how to route the packets, it's limited by the amount of data it can send in a single packet. Longer strings of data have to be broken down into multiple packets that need to be reorganized after sending. This can cause bottlenecks, and IP does not guarantee delivery or offer error checking like TCP does. Together, the TCP/IP protocol suite enables data transfer and communications across both the internet and other networks. Its functionality divides into 4 layers. The application layer, which provides applications with standardized data exchange. These protocols include HTTP, FTP, SMTP, and SNMP. The transport layer, which maintains end-to-end communications across the network. It usually uses TCP to control data flow and communications, but sometimes requires User Datagram Protocol, or UDP, instead. The internet layer, also called the network layer, which manages packets and connects networks to transport the packets across network boundaries, using IP and Internet Control Message Protocol, or ICMP. And the network link layer, or data link layer, which comprises protocols that only operate on a link. The protocols in this lowest layer include Ethernet and Address Resolution Protocol, or ARP. TCP/IP is a fundamental protocol suite because it's non-proprietary, can be modified easily to work with all operating systems, hardware, and networks, is highly scalable, and doesn't unnecessarily strain networks or computers. Despite its ubiquity, TCP/IP does pose some challenges. It's complicated to set up and manage. It's not easy to replace protocols. It's not suitable for describing new technologies in networks since it doesn't clearly separate the concepts of services, interfaces, and protocols. And it's especially vulnerable to denial of service attacks. TCP/IP is often compared to the OSI model, which is another communication standard. Without getting too deep, OSI is a more conceptual tool, while TCP/IP is a practical execution of network interactions. Did you know network protocols were so vital to digital communication? Share your thoughts in the comments, and remember to like and subscribe too.